Okay, so this part of the unit, we're talking about the laws of conservation of energy. And I have a skater here, and I have both a bar graph and a pie chart to kind of describe what we're doing with this skater. And so I'm going to put the skater at the top of the hill, and the pie chart is basically going to say that the higher I put the skater, the more energy they're going to have. And so you can look at it from the stance of the pie chart. And as they go down the hill, that energy turns to kinetic energy. And so that's the green, is kinetic energy. Okay. And if I do the bar graph, it gives the same type of a view, that the higher, the more energy, that's potential energy that it has. The potential energy is the resultant total energy that we have. So as I let the skater go down, you will see a couple things. You'll see that this blue turns to green and the blue turns to green. And so by the time it gets to the end, it's all kinetic. And so the gravitational potential energy that you have at the beginning, which is a full pie chart, and it's the full complement here for the potential energy here, as you go down, it begins to turn to kinetic energy. And if you get halfway through, you'll have half of it still potential energy and the other half is kinetic energy, and it will be transferred into kinetic energy in the end, all of the kinetic energy. Okay. The second scenario we have is that if you add friction. And so here I'm going to do the same thing. I'm going to start the skater off here, but this time I'm going to add friction, and you'll see that friction is called thermal energy. It builds up heat, and it is in slow motion, but it is going slower than normal. And so that speed there at the end is less by this amount. So let's take a look at this. This is probably about maybe 40%. So going down the hill, the skater loses 40% of the energy due to friction. This would be the same thing as if you were trying to slow yourself down with your foot going down Thunder Hill, or this would be the same thing as if you're trying to put the brakes on so that you're not speeding as you go down Thunder Hill. This would make it so that when you went through the stoplight at the bottom of the hill, right, you wouldn't be going 60 miles per hour, you'd be going 42 miles per hour. So 60% of the energy that was present at the beginning is still there in the form of kinetic energy, but 40% of the energy has been lost to thermal energy. So if I go ahead and reduce the friction down to 0, then you'll see that it goes a lot faster. All of the energy is put into kinetic energy in the end. And so there's no energy loss. Now that's obviously not possible in a real situation because the skateboard is always going to have friction. So when you're doing this on the quiz, there might be a different amount of friction for each scenario. This is less friction, so it will go slightly faster. It won't be 60-40. In this case, it looks like it's more like it's less friction, right? So this is probably more like 80-20. And so 20% of the energy was lost and slowed you down due to friction, whereas 80% is left over. So this is like putting on the brakes, but not putting it on so hard as the previous time. So anyways, hopefully that explains to you the idea we have for friction as you go down a hill and the law of conservation of energy, which turns the potential energy into kinetic energy.